All right, hello everyone. Welcome to ECS 179 Gameplay Programming. We just finished the first announcements, and we're going to talk about Exercise 2 now. All right, so let's go to Exercise 2. So we'll just open it up on the browser this time. Here's Camera Control Exercise Key. We're going to go directly to the README. And if you click on the README itself, you get rid of all the sidebars that are for the repository itself if you'd use the web interface for GitHub. Okay. Exercise 2 is about camera controllers like we talked about before. So this will be an addendum to the discussion section that we had on Tuesday evening. But the code and the description have all been very much updated for clarity. So I want to have a recording that we talk about the new version. And you can reference some of the things from the old. I just may not go into a lot of the niche depth that I did on Tuesday evening. All right, so your goal is to create several swappable camera control scripts for a top-down terraforming simulator. So we are building from Ite Karin's scrollback theory and practice of cameras and side scrollers. This link is now fixed. It used to go to the Gama Sutra article before they changed their name to GameDeveloper.com, and that link is now broken. But Ite Karin was kind enough to make that article accessible with a public Google Drive. So this is a link to that. And we've taken images from it to elucidate the types of cameras we want on the stages. Once again, stage 1 is worth 10 points, and the rest are 15. I misspoke earlier. I forgot the last one was also worth 15. I had inverted in my mind. Obviously partial portions are acceptable. We'll get partial credit for things. These stages add up to 70. As a reminder, the other 30% is your peer review of someone else's exercise too. I accidentally hit page down. The due dates will be on Canvas, but as we said, we'll give it out today. So it will be due next Thursday. Anytime midnight, so practically it will be Friday morning in the AM. Technically it's 5 a.m., but I'm not going to be up then. Okay. So each stage requires that you implement a type of camera controller. Each one of your 5 controllers should extend camera controller base. Ooh, and I forgot to remove the part about the namespace. We don't have namespaces, which I'm very sad about in GD script. So direct commit to master. Like we're playing fast and loose today, folks. Okay. Each of your camera control implementations should be added as a component to the main camera. Is this correct? Am I getting the right key here? Okay. They should be added as a component to the camera controller. So there'll be a minor update there. There's a camera controller to be very obvious when we go over this. I must have forgot to push a commit from my laptop. So looks like there's just a couple typos here that we'll need to fix. So you should bind the vessel node to the target exported field in the cameras via the editor. Only one camera controller script should be enabled at a time. We'll show you exactly how to do that. Yeah, okay, I changed all this from Unity speak to Godot speak. Just there must have been a commit here. So the thing here is we have a camera controller node that has a camera controller GD script associated with it, and that has an array of cameras, and you put all of your cameras into that array. You can have all of your cameras existing on the hierarchy. You put them all in the array, and the camera controller will help you swap through them. All right. We'll talk about which portions of the controller logic and controller variables you need to expose. And we talked about that you will need to use the immediate mesh to implement your draw logic function to show the camera logic for each one of your camera implementations. And we have examples in the push box camera class. And your camera should be immediately testable in peer review, so they should have draw camera logic set on by default. All right, number 1, position lock. Get your Terraria camera. There are no serialized or exportable fields in this class. It's pretty straightforward. I guess the only thing comes from the base camera object itself, which is the target that you'll want to add the vessel or player to. But you can draw a 5x5 cross. The size I don't really care about. Just make it like visible. This, like the ones that are just crosses in the middle that show targets, their length and width isn't really that valuable. You just need to know where the intersection is. The others, where there are boxes and borders, are much more meaningful, and those should be precise. Stage 2, framing with horizontal auto scroll. So here I changed the language a bit, and I changed the exported fields quite a bit to make it more understandable. So the idea here is that we have an auto scrolling box that will drag along the player. It should move on some direction on the ZX plane or XZ plane. I'm not sure why I put the Z first. It's not meaningful to me in this case. The plane where both those axes lie, defined by both those axes unit vectors. All right, so the box should be consistently moving on that plane at a speed. And you should have the player always be within that box. They cannot go out of it. If they are dragging behind the motion of the box should push them along. They cannot push the box, they are pushed by the box. A pull box? Your controller should draw the frame border when draw camera logic is true. All right, so here are your required exported fields. First is a vector 2 for the top left corner of the frame border box, and vector 2 bottom right for the bottom right corner of the frame border box. Right, and you can get the width of the box by taking the x of one minus the x of the other and absolute value it, right? Same with the heights and the y values. I'm just being very explicit and clear because that will be a question later, I'm sure. Now the big change here comes in the vector 3 auto scroll speed. So this is denoting both speed and direction. So here I am expecting that the y value of this should always be 0. You don't want to scroll up or down in this case. But if you want to have a 3D auto scrolling camera at some point, perhaps this could be interesting to you. So I'm leaving a place for it. So the speed of the camera and direction of the camera are both denoted by the x and z axes. So this is just like vectors and points in 3D space. They can denote a place, they can denote a direction, they can denote a magnitude. So by giving x and z a value, say 100 and 100, you will be moving at speed 100, 100 along that sort of positive 45-degree angle. Right, so with this, now you can move anywhere in any direction on that plane at any speed you'd like to move in. Yes?
So like for this auto scroll, is the plane be able to like get outside of the screen?
No, you're bounded by the box.
Okay.
The box is its home. It will not be able to leave its home.
Okay.
And if it does leave its home in your implementation, that will be a bad thing for your grade. Not
like
horrible, but yeah.
So like the box is like your screen or just like actually
It can be a portion of the screen. If you look at most shmups, you can't actually go to the exact pixel border edge of a screen. There's usually some buffer around the outside. So we're giving you implementation that you could make it the exact size of the screen, or you could make it with a border in a direction. You could make it like Rastlin Saga, right? Where it's in the top left, and it just pushes you in this small corner. Like that would be a really interesting shmup where you actually can only like move in like the middle like quarter of the screen, and everything else happens around you, and you have to do like really precise dodging, or rely on your wingmates to help out around you. Yeah.
So like if you're controlling the plane, is the velocity like respecting to the global or respecting to like the auto scroll speed?
Yeah, typically what happens, so I've seen both where you actually have to move right, like you're not inherently given a velocity by the camera. For this one, I encourage you to add that vector of motion to the velocity of the player. That actually makes the push box a little easier to handle, and also makes it so you're like this, where there's no motion, where the player's not controlling anything. The player stays in the same relative position on the screen, but the world moves around it. I encourage you to do that. And we got a lot of Discord going on, so we're gonna mute here for an hour. All right. Any more questions about stage 2? All right. It's a fairly straightforward camera to make, but understanding and asking these types of questions is good. Thank you. Good questions. All right, stage 3, position lock and lerp smoothing. So what I did, I know this was confusing, and this has confused a ton of people before. I'm actually taking out the requirement to use the lerp function itself, but we're going to have, we're doing an implicit lerp. So once again, this is a Super Meat Boy camera, where you can get ahead of the camera a little bit while you're moving, and then when you stop moving, the camera will catch back up to you. All right, so this kind of has the same feel of camera 1. It's not exactly position locked, but you will not stray very far from the camera central position. So here the major difference is it does not immediately center on the player as the player moves. Instead, it approaches the player's position and that is managed in the process function. It should follow the player at follow speed, a speed that is slower than the player, while the player is moving. The camera will catch up to the player when the player is not moving. This approach should be done at catch-up speed. So you have a configurable variable where the camera can do a slow crawl back to the player and be a little more cinematic, or you can have it something more precise. As soon as the player stops, it can zip right there at a very fast speed. Right, so you get to play with that parameter. And so that's a game feel parameterization. And finally, the distance between the target/vessel and the camera should never exceed leash distance. The leash is back. Bow, wow, wow. All right. So in this case, we're not breaking the leash like the follower. In this case, we are making sure that if the camera is at leash distance, we want to push the camera towards the player at camera speed, or at the player movement speed. Just basically, you can take the player's magnitude and direction of movement and add it directly to the camera, and you should be good. Okay. The linear interpolation or lerp for this camera is implicit in the parameterization and behavior, right? It is a catch-up mechanism over time. That's essentially what a lerp is. The problem is lerp is a iterative thing and you want it to run on its own and take control. We are in a process frame-based environment, so you have to do this awkward thing with a lerp to make it work, where while the player is moving, you're constantly resetting the parameters of the lerp every frame. And you only do a full lerp or let the lerp process on its own while the player's not moving. Because while the player's moving, the relative basis or the origin, the set basis for the lerp is changing. And you can't lerp when the basis changes, right? So you have to constantly update. So it's super awkward and confused a bunch of people. So I gave you this more quick and dirty implementation. If you want to do the full lerp and get that lerp style control, we're happy to help you during office hours. Right? Cool. Does that make sense? Is that clear? Okay, I have a little past class trauma for this one, so I'm just being extra cautious here. All right. And so this also includes a 5x5 or x by x unit cross, whatever makes sense for you. The exported variables are follow speed, like we described, should be slower than the camera. You can make this a raw speed. I kind of encourage you to make it a speed ratio, though, like say 80% of player speed. I will accept either implementation. Catch-up speed. When the player has stopped the speed, this should be how quickly the camera moves to catch up to the target's position. And finally, leash distance, as we described, that is the maximum distance the player should ever be from the camera. If they go past that distance, you should make the camera catch up to the player in some way. All right, questions about stage 3? All right, I can tell already there's less confusion in your eyes, so the explanation's already sinking a little better than Tuesday nights. Excellent, excellent. All right. Stage 4, lerp smoothing target focus. So this is the Jazz Jackrabbit 2 camera. It's basically very similar to Stage 3's camera, except you want to move ahead of the player. The center of the camera should move ahead of the player in the direction of the player's input. Look ahead camera. All right. Once again, this is another implicit lerp. The parameters are very close to the parameters for stage 3, the exported parameters. Basically, while you're moving, you move at lead speed, and this speed should be faster than the player instead of slower than the player, like follow speed was, right? I also encourage this to be a ratio of current speed. That'll be a little harder to manage with the hyperspeed boost in the terraforming project, because all of a sudden you're getting like, a 4 or 5x speed boost, and then that could push your camera to be, a large distance away. So that's where leash becomes even more important, right? You could immediately go past your leash on the first boost frame if the velocity is set high enough. So you'd have to manage that. Okay. Next is the catch-up delay. So unlike the LERP camera, you kind of want look ahead to stay look ahead for a little while, right? And so you should have a configurable duration where when you are out looking ahead and then the player stops moving, there should be a pause, a delay before the camera starts doing catch-up, right? And then that delay is configurable. It can be 0 in games where you want very fast camera reaction. It can be higher in games where you want to look around and see, like let's say a Metroid style game with look ahead, like Metroid Dread, for instance. All right, and then finally, leash distance. Same deal. That should be the maximum distance that the player and the camera should ever be from one another.
I have a question.
Yes.
How does the delay duration relate to, like, if the character's moving this way, stops, and the camera's going to be a little over here and has some idle time, but then if before the idle time's up, the character starts moving this way, should it?
You just ignore the idle time and start moving.
Right.
Start moving the camera at speed in that new direction.
Got it. Okay.
Yeah.
That answers it.
There is a definite priority of camera behavior here, and movement and follow and look ahead is one of the higher priorities.
Okay.
Highest priority, I think, in this case. Yes.
So I did some example here, the delay is 0, right?
The delay is 0 in this one. Yeah, yeah. This is making a camera that could be even better than Jazz Jackrabbit 2's camera. The luxury. Okay. Any more questions about stage 4? All right, here we go. Stage 5, the 4-way speed up push zone. Let's go. It sounds like an NFL commercial, right? Welcome to the NFL 4-way speed up push zone. Need like some horns. Okay. I'm half tempted to play a John Cena meme right now, but I will refrain. Okay, so the 4-way speed up push zone. This is like we described before. There is a inner box where when you move with inside that inner box, the camera does not move. Just like in Super Mario Brothers camera, there's a little area where you don't move, or the Super Metroid camera, there's an area where you don't move in the middle. So once you get in between or outside of this inner box, and between the outside the inner box and the inside of the larger outer box, so there's a box within a box here, there's a speed up zone when the player is between the two boxes. In the speed up zone, you should move at the direction of player movement. So if you're in the right side of the speed up zone, your right movement component should move at push ratio speed. So this is where we're going to use ratio. Like Mario's was around 80%, that'd be a great place to start. So if you're in like, the right border, let me just pull up the illustrative diagram instead of me like waving around my fingers like a loony, like a madman. All right, so we're doing the double box version here. So we have two boxes. In this middle box area, camera doesn't move. If you're between the inner box or the speed up zone box, if you're in between that box and the push zone border box, then if you were in this up area, all of your Y component movement will be moving at push speed ratio. Your X motion will be normal. Well, the camera won't react to the X motion here. Now, if you're in an X motion side, your positive X motion in this direction will move at push zone ratio, but your Y, either a positive or negative Y, will be moving normal, and your negative X will be moving normal. If you're in a corner, you're in both of these zone areas, right? So that means your up Y, or I'm sorry, your Z in this case, since we're looking down onto an XZ plane. Your Z motion will be at push ratio, your positive Z motion will be push ratio, your positive X will be at push ratio, but your negatives on both will be normal. Right, this making sense? Right, so we want to get that feel of the Super Mario Brothers camera while you're in that speed up zone, in that direction of movement, it's moving a little slower, so you have a bit of feel of acceleration and movement. And it would be a little silly if you were in this zone and then you had like weird acceleration movement going this way and then it stopped for a while and then you went the normal way again, right? So you want to make sure you look at the direction of movement and make sure the camera acts accordingly. Are there questions about this? 1 then 2.
So just like push ratio with respect to the player speed or the camera speed?
So the push ratio, that is the amount, the ratio of the player speed in which the camera is moving. So the camera wants to move just like the Mario camera. You want to move a little slower than what the player's moving in the push zone. That's the magic sauce to making it feel juicy.
I think you might have just said this, but I'm clarifying just because I wasn't 100% sure. If you're in the right blue portion, right there, right?
Yep.
But you're moving to the left, the camera should not be like taking it into account.
Yeah, the camera won't be moving. Yeah, exactly. Yeah, basically the camera won't be moving. It'll be like you're in this zone. All for that one directional component of that one axis.
Right.
Right. Yeah.
So you go to the person on the right, it'll follow you slowly, but if you stop moving, it'll keep moving until you're back in the middle of the box.
No, so if you're over here and you stop moving, the camera doesn't move. There's no catch up in this. The only time the camera moves is when you're moving in a direction of a speed up zone, in its direction towards the outside, or when you're up against the box and you're pushing the box. Then it moves at full player speed. This one's a little more complicated. This one, as far as I know, doesn't exist in any game. This is a concoction, a logical enhancement of existing cameras. We'll see how you like it after you implement it. I wonder if it's another Discord server that I'm getting things from. Okay. So the exported variables you have here. So basically what we just talked about is what this description's trying to say in more concrete terms. So here is the Mario example again, the push zone. This is like the inside of the push zone ratio. Notice when Mario moves to the right, it's pushing at a fraction of the speed of the camera, and then full speed when Mario hits the side of the push line. But then when Mario moves the other direction, the camera does not follow. Right. So basically, you're just taking this line, you're rotating it by 90 degrees, putting it up, taking another copy, rotating it by 90 degrees, putting it in the left, and then you're rotating it by 90 more degrees and putting it on the bottom. This is the idea. All right. And so push ratio, you need to define that ratio of speed that you use in the push zone. And we need to define the reaches of the two boxes. Right, so the speed up, so the push box left and right, top left and bottom right vector 2s are for the outer push box. The speed up zone top left and speed up zone bottom right are for defining the inner box. The rest is handled by your code. All right, what do you think? Should we look at some code? Logic brains engaged. Okay. Let's change the inspector a bit. Okay, so we're back to our world. So let me show you some enhancements. So first off, you can tell there's a deeper blue color now, right? Our oceans go deeper. And I got rid of the red out of bounds on the height. Added some appropriate spacey terraforming music. We can move around. Notice there's a shadow now, so you can tell kind of where you are above the terrain. We can turn the logic on and off. Controller support, first off. Yep. Zoom. Whoa. Zoom is also Z and X on the keyboard. We have our speed boost, along with sonic boom, and appropriate spacey mirror images to denote the speed. This isn't perfect. So if I keep going, the sound loops if I hold down the button. I haven't put in the code to fix that yet. Apologies for that. Didn't quite get that done. And if you tap boom, you're not constantly sonic booming. I thought that would be a little much. Okay, so there's that. And if you want to fix those things, I'm happy to take your implementations. Could be worth participation code or bonus points. Yes. This? Like how much I'm moving?
Yeah. So like the joystick, like how, is it gonna be a constant speed or like change?
Oh, so it respects the partial velocities involved with the joystick. I haven't configured the dead zone is 0.5 right now out of 1, and that was the default in Godot, so it's hard to tell. Here, let's go ahead and see if we can change that real quick and just show you. So this is also worth showing off. You can see inside of the input map, I added a bunch of things, right? Fire 1, zoom in, zoom out, raise and lower terrain, camera tilt left and right, which is a partial implementation of there. If you want to be brave and rotate around the Z-axis and weird yourself out and maybe get seasick, go for it. Motion sick. And then cycle camera controller. So these are actions that I added. So for those are not the built-in ones. So if we want to go to the built-in ones with UI left and right, we can change the dead zone. So let's change the dead zone going right to 0.1 instead of 0.5. And let's see if moving right now has more visible nuance. I think the speed's just too fast. But it in the code, we'll take a look at it, and you'll see directly we're just getting the axis information from the controller, which is a float value from 0 to 1 in each direction. No, all this should be abstracted for you. Your cameras just need to look at what speed, the velocity of the player, and that's kind of all the information you need to know. And that way, if you just look at the speed, your camera will work for both boost and just normal movement. All right, so we have speed, boost, we have our mountains, we have our deep water. We also, with L and R, we can change the height of the world. We're making mountains. We're deforming meshes. And this value I set to be a little low. You can have more deformation if you'd like. All right, so now you can let's make a nice little green area for whoever's gonna live here to have a nice little like place to build houses. Little grass, happy little grass. Bob Ross is an American hero. Now, I grew up near his mansion. My sister was almost on his TV show where he would have, near the end of his life, where he was playing a tree, and his face was just in the middle of a tree, and kids would like frolic around him and be like very, very Mr. Rogers-y. Anyway, lore for another day. Right, so we made some nice green space. So we can terraform our world. And this is a deformable mesh, and now there's the code in here to change these. This can be a little resource intensive. So notice like I'm pressing button here and it's moving all the way up there. That's finding the nearest vertex. If you want more fidelity and you have a faster computer, feel free to bump up the terrain vertex numbers. And so you'll get more fidelity out of that. Tunable. It's tunable. All right, so we have all that. We have training, we have up and down, L and R. We have cycling between different cameras with R2 or R, the R keyboard button. And so that's handy. If you want to test your cameras, you can just cycle through them very quickly. Notice, but when the cameras cycle, I do turn off the draw logic automatically in the camera controller. So just keep that in mind. Terraforming sound, little laser hiss. Nothing too grating because you're gonna have to listen to it a lot if you play around. All right. Now we played a little bit. Questions on this? Just the UI or anything? Yes.
Zooming in and out the draw box in like the bounds changes. Yeah, okay, so it gets bigger.
Yeah, it does. So that's why we are drawing the boundaries at the same Y plane as the player. Right? So when perspective changes, it stays consistent with the player. Perspective division isn't making it worse. So notice that the player is like, touching the borders of the box just barely, right? And it's very much looks like the pushing the box. That still holds when we zoom out at any scale, right? It's a conspiracy. It's flat Earth! No! Oh yeah. It's your job to make sure the world doesn't fall into oblivion by making ice walls around the entire edge. Speedrun ice wall. Speedrun ice wall. Slowest speedrun. Okay, ice. Whew. One portion is safe. Science. All right, any more questions about this before we look at the code? Yeah. It is dynamically computed. It's not ray traced. It's using a more like easy standard algorithm that is not as intensive as ray tracing. I believe you can turn on ray tracing. I don't know how to do that. I haven't looked at ray tracing in Godot yet. I don't think this could handle ray tracing. The Steam Deck? It would explode. Yeah. But we're essentially doing ray tracing algorithms here when we're looking. I kind of rolled my own ray tracing when finding the nearest vertex in the plane. But yeah, if you want to play with ray tracing, let me know. I'd be happy to have you teach me. Portal with ray tracing is magical, by the way. If you played that Portal ray trace demo, yes. Uh-huh. Yeah, if you'd want to, absolutely. So what you'd have to do is have your camera, like your push box one camera, you'd have to change the box height and width dynamically to handle it. So, I mean, let's go ahead and just change the border so I show you that it's working and make it 40/40 instead of 10/10. I had a bug in it when I showed it to you on Tuesday, but that bug has been fixed. All right, so now we have our bigger border. Yeah, so you would I have not implemented that. You have the tools here to do it. I'm showing you that the box can be dynamically, push box in this implementation can be dynamically configured at runtime. You would have to do the math to keep the perspective, the on-screen perspective to be the same. And that's actually not as bad as it looks because you can peg screen coordinates and then do the screen coordinate to global coordinate transformation, right? And that's easy, Godot gives you easy functions to do that with. If you're doing it in, let's say a shader, then you have to do some matrix multiplication, an inverse matrix multiplication. All right. Let's take a look at some of the implementation. So stuff has changed. Is it big enough? Can you all see the editor and see the things? Okay, I can make the editor size a little larger. All right, cool. All right, so we still have our world scene, which is our base scene for the experience. We have our vessel. Our vessel has its own scene. So inside the vessel is a 3D sphere, which is the vessel itself. It's smushed a little bit, so its Y is scaled down to make it a little bit of a skittle. And we have a collision shape 3D, which is a sphere. Not that we're colliding with anything, but it is there just to be used in the future if one needs it. And we have a particle trail. This is, I'm using a 3D GPU particle emitter, a particle system, to have that speed boost trail with the mirror images. So if you look inside of that, you'll see that I've modified quite a bit about the particle system. I've modified the rate at which it operates. I've modified the direction through which the particles are generated. I've turned off gravity on the particles. I've made the particles have a randomized hue and alpha value, so that it looks a little bit like blinky and shady. I've changed the lifetime of the particles so it extends to the trail length that I was comfortable with. And so there's several things in there to look at if you want to dig into that particle system. We have our audio listener 3D. Didn't have time to do this. So if you want a bonus challenge, what I wanted to do was when you move fast and did a sonic boom, I wanted to drop that noise emitter at the place where the sonic boom originated from. So while you move away, you can have the positional audio from the sonic boom be handled for you. So that could be something you could do. I don't think it'd be too hard. You just add it as a child of the world at a particular place and just move on without it. And you probably have to generate a new one every time you boom. All right. And we have our audio. We have our terraforming audio, which is the laser noise. It's a randomizer, but I'm not actually using the randomizer now. It's a hissing sound. It's a little long. I would probably, if I had my druthers, I'd chop it to be about a third of its length in a loop if I needed. Hyperspeed. Let's turn the volume back down a little bit because this one's a little loud. Right. Boom, sonic boom. It was a cannon shot, an explosion. But I think it worked pretty well for the sonic boom sound effect. All right, so that's... I'm sorry?
The pirates are haunting us.
The pirates are haunting us. Something interesting, if you want to look in here, Godot has a little bit of functionality it needs to handle particle emitter transformations over time, moving at velocity. This is a bit of patch code to make sure the transform updates in a fast way. Otherwise, when I was moving at hyperspeed, it was laying down patches of particles, and it didn't look good. So I ended up finding someone's code. I should put the URL. It was a GitHub issue that someone put a patch for it like 2 years ago and hasn't been fixed quite yet. Okay, we also have the vessel code here, the vessel implementation. So some things have changed. Control B, no, S, no, what was it? Oh, now I forget what the, getting rid of the bottom key was. It's annoying that some of the hotkeys are different from OS X than Linux and Windows. So I struggle. All right, so we have a terraforming power. That is the amount of elevation in world coordinates that each unit of modifying the terrain does. The terrain roughly goes up to a maximum height of about 15 for the generated snow peaks and negative 15 for the deepest water. I had it actually set to 0.1 in the version I showed you, which is why it was taking forever to move it. I was playing around. And we have our terrain manager. This is the code, the object, the class that modifies, that generates and helps us modify the terrain. We have the radius of the ship. I was in the middle of dynamically inferring the radius based on the size of the sphere and the scale of all the objects involved, but didn't quite get there. Wasn't super important. Didn't feel like the best way to spend the time. Base speed is 50. Hyperspeed is 300. Feel free to play with that if you'd like. So there's a 6x speed boost when you go into hyperspeed. In atmosphere, it's a very risky operation. And then we have our physics process. This one uses physics process because we're dealing with velocities. You'll see the cameras, I use just process because I'm dealing with positions directly and not with the physics system, right? So things that, this is sort of like how I'm learning to break this down, since there was a question about this previously about when to use underscore process and when to use underscore physics underscore process. And the best practice I can find right now is if you're interacting with the physics system in some way, setting velocity, utilizing gravity, you want to be in physics, the physics version. But if you're just dealing with positions, animations, that sort of thing, you should do it right in process because it'll run more quickly. You have more control over it. Okay. UI accept makes hyperspeed go. Raise terrain makes raise terrain go and plays the terraforming sound. Input direction, so here's how we're getting input that works with both keyboard and with controller. So what we're doing is we're getting the strengths of the left and right actions and up and down actions. We're making vector 2 out of it and normalizing the length. And then we are making sure that we get this. There's an extra set of parentheses around this because I was dealing with transform bases. I was playing with rotation. But I sort of like took that out. So we're getting normalized version of the direction. And then we are adding the direction plus speed to our velocity. And then if we don't have a direction, we're going to use the move toward command. This is default. I don't think the code actually ever does this. But this was given by the template. And then move and slide. And then we have our play command, which is for playing sound. The safe sound play, so you don't keep playing the same sound over and over again. Like particularly if you hold down boost and you don't have this in, it'll every frame restart boost. So it'll just be a cacophony of shockwave sounds in your ears. All right, so that's all of Vessel. Other things we want to look at are camera. So there's a base camera scene here that has just a camera to camera controller in it, just a convenience for you to help. You can drag this into the scene, make a new version of it, and then modify it to be your own camera. You can detach the script that's there and add your own camera script that extends camera controller base. Taking a look at this, this does a few things for you. I'm sorry, that's the push box camera. Why did it move to that? Okay, great. So here's camera controller base. It extends camera 3D as one would expect. It has a target, and we're setting target to be of class Vessel for this. If you had like players, characters, whatever, you could change the class of this and it would help you particularly auto select in the export editor area which things in your project would match that definition. We have distance above target, which is the thing we modify for zoom. We have zoom speed, so if you want it to zoom faster or slower, you can modify this value. We have the minimum zoom and maximum zoom. What's the minimum height above the player and what's the maximum height above the player the camera will be. And then we have our draw logic command. So this exists for you in the camera base, so you can just use it as you would the parent option of any other class. There's some variables here if you want to uncomment plus a block of code later to deal with Z tilts in the camera. It's not 100% working yet, so I didn't include it all the way. We have ready. So here we're making sure that all the cameras are turned off by default, and we only turn on the one that we have the active camera in the camera controller first. So current is a camera value. And then we're giving it an initial position, or I guess adding its position, we're making it a little higher. So it targets the player and then goes up a little bit. And our process, we have fire 1 that turns off and on camera logic as a toggle. And then we have zoom in and zoom out baked into the camera and Z tilt. And then finally, we do the final position of the camera based on the target and distance above the height of the camera. So this camera, this base camera, if you put it in, it works. It shows a screen. It doesn't track it all though. But you can zoom in and out. You can Turn on draw logic, that does nothing. No, we don't even call draw logic. Do you call draw logic? Okay, yeah, so I left that for you to do in the cameras. Okay, so that's the basics of the camera base class that you will then be extending. Let's move on. Geez, we're using all this time. This is actually taking longer than I thought it would. We may not get to mechanics and dynamics today, but I think this is valuable for you to know to get started. I made 3 copies of push button camera in here just to show you that the camera selector works. So the camera selector class simply has which one of these cameras do you want? So it has an array here, and you can keep adding elements to the array and keep putting in new cameras. It has some tolerance for null spaces in the cameras, but I didn't spend a lot of time bug fixing everything. So for your own usage, just make sure if you have an element here, it's all full. It's a standard array modifier, so you can like add a bunch of elements to it if you want. You can assign them, and because it's looking for camera controller base derived things, all the things in your project that exist that are camera controller bases you can include. So a little nicety there for you. You can delete elements like this. Yes.
And then is the default camera it selects is just 0?
The default camera it selects is 0. I couldn't get this right off the get-go. For some reason, I thought I had the code correct. When I had this current controller exported, you could select which camera you wanted at the beginning, and it just, for some reason, I couldn't figure it out. I ran out of time. It wasn't quite working. So if you want to do an easy patch, like the code is down here, well, it's on ready right here. And so you can see length of camera controller is less than current camera controller +1, camera controller gets current, right? It just, for some reason, there's some logic error, wasn't working, haven't figured it out yet. But you could put that in yourself, export this variable, and you have easier testing. I recommend it. Or otherwise it does 0, so just put the camera you're testing in the 0 slot. Okay, so basically this is just managing camera controllers. Particularly we have here the cycle camera controller command, which we had inside of our input list. That is set to R2 on controller and set to R on the keyboard for cycling cameras. And you can see what's going on here. We just increment the current camera controller, and if we go over, we pop back to 0. We want to make sure that our camera controller, that all the other camera controllers are turned off and their draw logic is turned off. And we want to make sure that the current camera controller we have is made current. So its current is equal to true. And then we do some detection here just in case we've somehow got a current camera controller that was null. Handle it in some way. Find a camera that works. Basically is all this does. All right. Any questions about the camera selector? This is meant to be a convenience for you to help you test out the project. And to give you a paradigm, like if you wanted multi-camera control, like you did like a prison panopticon surveillance game for your final project, you could easily like flip through different cameras and be kind of creepy. Halloween. All right. I didn't see any hands, so let's go look at the pushbox camera script again. So pushbox camera. So what I want to show off here is we have the pushbox portion of it, which exposes or exports the width and height of the box. We also have the camera controller base. So these are all the exports from the base class. Notice that they're separated, so you know where the stuff is defined and where items are. Draw camera logic is in the base class. All right, so our pushbox camera controller. I cleaned up the code. I saw the confusion happening when you saw all that math and then it was repeated like twice. So what I did here, so most of the code is the same except for current. I'm making sure that you don't process anything if you're not the currently active camera. Draw logic. We've got our global positions. So here, I made this a little easier to understand. The math here, I made explicit. So the first thing we're calculating here is the difference between the left edges, the left edge of the box and the left edge of the vessel. Yes. Oh, you're okay. See, hands are going up. Like right. So we're seeing if the left side of the target is to the left of the left side of the bounding box. And so if that difference is negative, meaning it's to the left, we move the camera that much to align the left edges. Same with the right, same with the top, same with the bottom. So I'll let you look at this code. Maybe, I hope it's a little easier to understand now that it's broken up in this way with variable names and things. If you still have problems with it, let me know. And then we call super to make sure if you want to do this with all your cameras, there's functionality in the base class that you want to call on your behalf. So make sure you call super with Delta. You also want to call super with ready as well. And then we have draw logic. So once again, this is creating a new mesh instance 3D. So we have a new thing we can put on the world that has a mesh. We are giving that mesh instance 3D, which manages meshes for you with things like properties and shaders and all that. We are giving it a new chunk of geometry to plunk into the world. We are creating it with the immediate mesh, and we're giving it a basic material 3D to give it the shading that we need. So we are setting the mesh instance to immediate mesh. We are making sure that shadows for it are off. If you want shadows near your bounding box on, feel free. It's kind of fun. We are calculating the left, right, top, and bottom corners of the bounding box in local coordinate offsets. And we are making sure that we are going to start drawing a surface. That means drawing the geometry. All these are shell computations, shell algorithms to infer a shell over sets of edges and vertices. And so we're doing that with primitive lines. Primitive lines means every pair of vectors you give it draws a line between those two. They don't have to be connected, which is how you can do a cross. I guess you could do a cross by like going down, up halfway, left halfway, and then all the way right, but you don't have to. Top to bottom, left to right. Okay, so we're adding top right to top bottom. So we're drawing the 4 lines. We don't need to go over this in that much detail again. Making it unshaded, making it black. You can change the color if you want. Just make sure it's visible. And then we are adding it to the tree. We're make sure we align it to the proper global position that we want it at, and we're make sure we're respecting the target's Y position in particular. After we've added it to the scene, and then we are making sure we get rid of it on next process frame. This was in physics process frame before. I changed the process frame now since it isn't actually dealing with the physics system. Okay. Questions about Pushbox? A little more clear now the second time you've seen it with slightly cleaner code? Excellent. Excellent. All right. I guess we should just keep going with this. We don't have time to do the stuff. We'll do lecture on Tuesday. I would rather you have learned direct gameplay programming by looking at a fun example that takes priority in class. All right. So basically all these cameras, the only difference between them is I've changed some of the export parameters. That's it. Direction light, nothing really going on there. It's a light. It's slightly angled. Our terrain manager, I guess, so we have our audio player. The audio player has a track in it, which is a looping track of our spacey terraforming music. It'll get seared into your soul, I'm sure, just like elk screams. Sorry, not sorry. And so we also have a second track that you could use, much more of like fusion, jazz, Nintendo stuff. Right. And both are like 30-ish second loops. And they both fit. Like when I'm playing it, I can feel both, right? I'm cosmic. One, I'm more like Katamari Damacy.
It's like a nice relaxing.
Yeah, we're just making some grass. All right, terrain manager. Okay, so we went over the terrain manager a bit last time. I cleaned it up. Turns out like doing this is actually still kind of a hot mess in Godot. It wasn't much better in Unity. Turns out just doing dynamic vertex manipulation on the fly is just kind of tough no matter how you do it, because you're working in a pretty heavy game system. There's a lot to do here. But one thing to point out is that every time you change one of these editor values, it calls generate terrain. So when you toggle those, it will go through the entire terrain generation process again. That way, if you flip through the seeds and find a world you like, go ahead and put it in there. Elite world. And the amplitude here is the difference between the lowest point and highest point on the mesh. All right, ready to generate. We don't need to go through all this. We have our mesh tool. Our initial generation of the plane comes from making a standard plane mesh and then copying its dots. We want to make sure we're ready to generate, just plane keeping stuff. We're making sure that our values are the things that set the height, width, and subdivisions of the mesh. The big thing here is we are giving a seed to our noise machine, which is using noise light 3D noise light. I forget the name of the class. But basically, we're going through that mesh that we had generated for us by the plane. We're going through each mesh individually, getting its vertex information, making the noise channel be the height. So we're inferring height. If you want to do this all with shaders, you could make a height map texture and do it that way, and then you can match the height map texture to the collision surface texture, and it works all quite nicely. I didn't have time to learn all that. I haven't done that before. Okay, so we are modifying that mesh. We are setting that mesh index back to our newly modified values. So we're updating the heights. Then, and this is the part that was really tripping me up, you want to clear the existing mesh's surface. So all the existing mesh information is gone and all the data structure is ready to accept new things. You want to add your mesh, since all of these are technically multi-mesh surfaces. You can have different meshes. You can have mesh 0, mesh 1, mesh 2, mesh 3, all in the same mesh instance. So we want to make sure we commit our surface to mesh 0. Then, for some reason, we have to clear it again and then commit the thing to surface without a mesh number. I have no idea why Godot wants this. I have yet to figure out the engine parameters that make this a thing, but this is how it has to be to work. It will take the first commit and run with it. The problem is, once we get down here to move vertex below position function, where we want to take that mesh that we modified and then modify it again and lock it back in again, it needs that two-phase protocol, or else it just zeroes out all the heights. Don't know. It works here. There's mysteries in the universe beyond my comprehension.
Terraforming is one of them.
Yeah, exactly. Flat Earth terraforming is just way past my brain. All right, so basically, we're doing something stupid and inefficient that doesn't scale well. We're actually going through each vertex and finding the closest one. I tried for about 2 hours last night to figure out how to take an XY position and find the index within that plane. All of those values sort of changed when you attach the mesh, and I did all this math to find out the X and Y correspondence and to reverse engineer how they place the mesh vertices in triangle strips. Just to no avail. I haven't nailed it yet, but that is the goal: is to simply give it an XY value and to infer the index inside that mesh that you want to modify. Modify it just that one, only touch it, lock in those changes, and have it go. There's a reason why you have to tap and the terrain pops instead of being a continuous movement like I've done in the past versions of this project in Unity. It's because now if you hold this down, if you turn on the FPS, like if you turn on the label that I have FPS going on, you'll see like I'm usually steady butter smooth 120 on this, and then as soon as I deform a mesh, it goes down to 100, right? Now if you do that once every frame and you hold down terraforming, it's bad. Now, what you could do if you wanted more continuous things is you could throttle it and only do it like once every 30 frames or something like that, right? And do it like 4 times a second, which would still look fairly continuous as far as like the terraforming goes. So feel free to fix that if you want. This is a base implementation. I also gave you a small mesh to start off with, so this goes relatively quickly. If you have a fancier computer, feel free to make the mesh wider and have more subdivisions so you have more geometry to play with. It'll make the terraforming look better. It'll make the syncing of where your ship is to where you terraform more legible, more close. So there we are. And here you can see we're setting the vertex that we changed by the delta value and doing the double lock-in. Wipe lock-in, wipe lock-in. Confounding. Okay, I think that's basically all the code that you'll look at. You'll see there's some other files in here. Well, there's the debug, the camera slip, which we looked at. We have our debug camera, which is just simply some debug text for a label attached to the cameras, just in case you want to get some info at nicety. And we have a GPU particle fix for the particle emitter. So there's less individual assets and code files in this, but I think the complexity of each one is more significant. All right, 5 minutes left for questions. What do you think? You holding up euros? Lira. I don't take bribes. All right, any questions? I will have this posted for you. I'm hoping to get it done right after class. We just need to update the GitHub repository and put it into a template with the exercise. No matter what time I give it to you today, it'll be due next Thursday, midnight, anytime on Earth, or before we wake up and take a cut. All right. Another day, another set of gameplay programming. Take care, everyone. Have fun. And Nick, do you have office hours on Friday?
Yes.
Okay.